Hi, our lesson for today is all about conditions for parallel or perpendicular lines and segments. In the previous lesson, you learned how to prove the properties of parallel lines cut by a transversal and the measurement of the pairs of angles formed. Parallel lines cut by a transversal are evident in a real-life situation, like roads and railway crossing, window screens, staircase and the railings, road maps, badminton, tennis or volleyball net, score sheets, rule notebook and ledgers, checkered dress and stripes, and many more presented in the illustration on the slide. In this lesson, certain postulates and theorems can be used to guarantee conditions that lines and segments are parallel or perpendicular. Let us start by recalling the fundamentals of parallelism and perpendicularity. Did you know that the idea that parallel lines exist and are unique is a fundamental principle in geometry? In Figure 1, the dashed line represents the only line that can be drawn parallel to line M such that it passes through the point A. From this condition, a parallel postulate was concluded. This is the parallel postulate. Given a point and a line not containing it, there is exactly one line through the given point parallel to the given line. Two lines are parallel if and only if they are coplanar and they do not intersect. Two lines or parallel lines is the symbol used for parallel lines. Or it's just like two capital letter I. Parallel lines can be shown by the following figures. The first figure, the second figure, and the third figure. Parallelism is not only limited to lines but in segments as well. Consider another postulate. Two segments are parallel if and only if the lines containing them are also parallel. Now, in Figure 2, the paired parallel segments formed are the following. We have line segment KO is parallel to line segment JN. Next, line segment IM is parallel to line segment JN. Next, line segment HK is parallel to line segment IJ. Next, line segment line segment OL is parallel to line segment KH. Next, line segment KO is parallel to line segment HL. Next, line segment ON is parallel to line segment KJ. Next, line segment JI is parallel to line segment NM. Next, line segment ON is parallel to line segment LM. Next, line segment HL is parallel to line segment IM. Next, line segment KJ is parallel to line segment HI. Next, line segment NM is parallel to line segment OL. And last, line segment HI is parallel to line segment LM. Aside from parallel postulates, a perpendicular postulate was also determined. We have the perpendicular postulate. Given a point and a line not containing it, there is exactly one line through the given point perpendicular to the given line. A reverse capital T is the symbol used for perpendicular lines. In the accompanying figures on the slide, lines M and N intersect at point A to form right angles. We can say that using a perpendicular postulate, line M is perpendicular with line N. In symbols, we write M is perpendicular to N. Observe that small squares indicate that the angle formed is a right angle. Thus, perpendicular lines form 4 right angles. When two or more lines intersect or cut by a line at different points called transversal, certain conditions guarantee which lines and segments are parallel or perpendicular. A transversal is illustrated in the slide. Line P is a transversal of parallel lines M and N. Based on the exploration of parallelism and perpendicularity of lines and segments, the following postulates and theorems generalized some conditions that guarantee in which lines and segments are parallel or perpendicular when cut by a transversal discussed in the slide. So now, let's proceed first with CACP, or the corresponding angle congruent parallel postulate. Given two lines cut by a transversal, if corresponding angles are congruent, then the two lines are parallel. So we have our illustration. For this, we have our statement. If angle A is congruent to angle E, then M is parallel to N. Next, we have the AICP, or the alternate interior congruent parallel, or the alternate interior congruent parallel theorem. Given two lines cut by a transversal, if alternate interior angles are congruent, then the lines are parallel. So again, we have our illustration on the slide. And for our statement here, we have if angle D is congruent to angle F, then M is parallel to N. Next, we have the SSIAS, or the same side interior angle supplementary theorem. Given two lines cut by a transversal, if same side interior angles are supplementary, then the lines are parallel. So from our statement here, we have if angle D and angle E are supplementary, then M is parallel to N. Next, we have the AICA, or the alternate interior corresponding angle theorem. Given two lines cut by a transversal, if alternate interior angles are congruent, then corresponding angles are congruent. So for our statement here, if angle A is congruent to angle B, then angle B is congruent to angle C. That is our AICA theorem. Next, we have the three parallel lines theorem. In a plane, if two lines are both parallel to a third line, then they are parallel. So for our statement here, we have if M is parallel to if M is parallel to L and N is parallel to L, then M is parallel to N. Next, we have the perpendicular to a third line theorem. If two coplanar lines are perpendicular to a third line, then they are parallel to each other. So for our statement here, if L sub 1 is perpendicular to line P, and L sub 2, or the line L sub 2 is perpendicular to line P, then L sub 1 is parallel to L sub 2. Now, after knowing the postulates and theorems that determine conditions for lines and segments that are parallel or perpendicular, let's refer to the following examples on the slide to enrich your understanding of the topic. Now, for our example number 1, the figures on the slide show a postulate or theorem that guarantees that lines M and N are parallel. So, for our first figure, and the postulate here or the theorem is alternate interior congruent parallel, or the AICP theorem. For our next figure, the postulate here is what we call the corresponding angles congruent parallel, or the CACP postulate. For our next figure, this is the SSIAS theorem, or the same side interior angle supplementary theorem. For our next figure, this is what we call the three parallel lines theorem. Next, for this figure, this is what we call the perpendicular to a third line theorem. That is our first example. Now, let's proceed for our illustrative example number 2. Using figure 3, let's give the condition on the given statement why D is parallel to E. So from here, we need our 2-column proof. So again, from this 2-column proof, we have our statement and condition. So now, for our first statement, if the degree measure of angle 6 is equal to 80 and the degree measure of angle 8 is equal to 80, the condition here is by corresponding angles congruent parallel, or the CACP postulate. Next statement, if the degree measure of angle 2 is equal to 80 and the degree measure of angle 3 is equal to 100, the condition here is the same side interior angle supplementary, or the SSIS theorem. Next statement, if the degree measure of angle 3 is equal to 115 and the degree measure of angle 7 is equal to 115, the condition here is by the alternate interior congruent parallel, or the AICP theorem. Next statement, if the degree measure of angle 2 is equal to 84 and the degree measure of angle 6 is equal to 84, the condition here is by alternate interior congruent parallel, or AICP theorem again. And for our last statement, if the degree measure of angle 6 is equal to 75 and the degree measure of angle 7 is 105, the condition here is the same side interior angle supplementary, or the SSIS theorem. That is our second example. Now, let's proceed for our example 3. Let's identify the parallel lines in the given figure. Let's justify our answer by stating the postulate or theorem. So given the figure, let's identify the following conditions, the parallel lines, and the postulate or the theorem that apply. So we have line segment DU is perpendicular to line segment DU is perpendicular to line OT, and line segment DU is perpendicular to line MS. The parallel lines here are OT, or line OT, and line MS. The theorem here is the perpendicular to a third line theorem. Second condition, if the degree measure of angle 2 is equal to the degree measure of angle 6, the parallel lines here are line UO and line SD. The theorem, the alternate interior congruent parallel, or the AICP theorem. Next, if the degree measure of angle 1 plus the degree measure of angle 2 plus the degree measure of angle 5 is equal to 180, the parallel lines here are line OT and line MS. The theorem is the same side interior angle supplementary, or the SSIS. Sorry, that is the SSIS theorem. That is S, sorry. Next, if line segment DU is perpendicular to line segment MS and line segment TS is perpendicular to line MS, the parallel lines here are line segment DU and line segment TS. The theorem is the perpendicular to a third line theorem. Next condition, if angle if angle 4 is congruent to angle 7, the parallel lines here are line UO and line SD. The postulate is the corresponding angles congruent parallel postulate. Next, if angle 6 is congruent to angle 9, the parallel lines here are line segment DU and line segment TS. The theorem here is by alternate interior congruent parallel, or the AICP theorem. Next condition, if the degree measure of angle 4 is equal to 78 and the degree measure of angle 7 is equal to 78, the parallel lines here are line UO and line SD. The postulate is the corresponding angles congruent parallel postulate, or the CACP postulate. And for our last condition, if the degree measure of angle 1 is equal to 50 and the degree measure of angle 4 is equal to 50, the parallel lines here are line DO and line UM. The theorem is the alternate interior congruent parallel, or the AICP theorem. That is our example number 3. Now, let's proceed for our last example. Now, given using the figure below, let's answer the following question. Let's answer first the first question. If the degree measure of angle Q is equal to 3x minus 10 and the degree measure of angle S is equal to 2x plus 45, let's find the indicated measures of the degree measure of angle Q, angle R, angle S, angle T, angle U, angle V, angle W, and angle Z. Now, so from this question, we will have our solution. Now, angle Q and angle S are corresponding angles. That is by corresponding angles congruent parallel, or the CACP postulate. Corresponding angles are congruent. So, the degree measure of angle Q is equal to the degree measure of angle S. Now, let's substitute the value. So from here, let's apply the addition property of equality to cancel 2x by adding both sides by negative 2x. So 3x plus negative 2x, we will have now our x, and then bring down minus 10, and 2x plus negative 2x, it will be cancelled and bring down 45. That is our resulting equation. Now, from here again, let's apply again the addition property of equality by adding both sides by positive 10 to cancel negative 10 on the left side. So we will have now x minus 10 plus 10 is equal to 45 plus 10. So we have now x is equal to 55. Okay. After we find the value of x, which is 55, we can now find the degree measure of angle Q and the degree measure of angle S. So from here, let's find first the degree measure of angle Q. Again, the value is 3x minus 10. And after that, let's substitute the value of x, which is 55. So we will have now 3 times 55 minus 10. So 3 times 55, we have 165 minus 10. We have now 155. So therefore, the degree measure of angle Q is 155. Now, let's find now the degree measure of angle S. Again, the value of the degree measure of angle S is 2x plus 45. Let's substitute again the value of x, which is 55. So 2 times 55 is 110 plus 45 is 155 also. So therefore, the degree measure of angle S is 155. So now, let's find the indicated measures. So we already find out the degree measure of angle Q, which is 155. Now, let's proceed to the degree measure of angle R. Since angle R is supplement with angle Q, so therefore, the degree measure of angle R is 25. Now, let's proceed to angle S. Since we already find out what is the degree measure of angle S, that is 155. Now, let's proceed now to the degree measure of angle T. Since angle T is correspond to angle R, therefore, the degree measure of angle T is 25 degrees. Now, let's proceed to the degree measure of angle U. Since angle U is supplement with angle Q, therefore, the degree measure of angle U is 25. Now, let's proceed to angle V. Since angle V is the alternate interior with angle S, therefore, the degree measure of angle V is 155 degrees. Next, for our angle W, since angle W is correspond to angle U, therefore, the degree measure of angle W is 25 degrees. And for our last, since angle Z is correspond to angle V, therefore, the degree measure of angle Z is 155 degrees. Now, that is our first question for our fourth example. Now, given the same figure, another example, let's find the value of x that will make O or line O is parallel to P. The degree measure of angle T is equal to 5x plus 17, and the degree measure of angle Z is equal to 3x minus 5. So for number 2, angle T and angle Z are supplementary. By same side interior angle supplementary or the SSIS theorem, the degree measure of angle T plus the degree measure of angle Z is equal to 180 degrees. And now, let's substitute the value. So we have now 5x plus 17, which is the value of angle T, plus 3x minus 5, which is the value of angle Z, is equal to 180 degrees. Let's combine similar terms. So 5x plus 3x is 8x, 17 minus 5 is 12. So we have now 8x plus 12 is equal to 180. And after that, let's apply the addition property of equality by adding both sides by negative 12 to cancel positive 12 on the left side. So we have now 8x plus 12 plus negative 12 is equal to 180 plus negative 12. So 12 plus negative 12, it will be cancelled. So the remaining will be 8x. And 180 plus negative 12 is 168. And after that, let's apply the division property of equality by dividing both sides by 8. So 8x divided by 8 is 1x or x, and 168 divided by 8 is 21. So therefore, the value of our x is 21. So now, to check if our answer is correct, we just substitute the value of x, which is 21, to 5x plus 17 and 3x minus 5 to prove if line O is parallel to line P. I hope class you understand our lesson for today, which is the conditions for parallel or perpendicular lines and segments. Thank you for watching.